We are SETS Puljok, a chapter of SETS Nepal. And today we are joined here with Miss Samira, and she shall be giving a presentation on Earth and Planetary Science and the current initiative of SETS Canada. And that's it. She is also the president of SETS Canada. And I shall hand this platform over to her now. All yours, Samira.
Thanks, Sumit. I'm just going to start sharing my screen now as well. So I will try and let me know if you see it. Oh, sorry. I think Rohani has to stop sharing the screen. Sorry, Roshani. And then I can start as well.
Roshni, can you stop the screen sharing?
Awesome. Do you see my screen?
Yes, we can see that.
Awesome. Okay. So hi, everybody. Thank you for having me and inviting me to come give this talk in your series. My name is Shamira. Nice to meet you. I am the president of SEDS Canada. And if you don't know how to pronounce my name, it's okay. I will give you a little bit of tutorial later. So I'm going to be presenting and familiarizing you about the Earth and Planetary Sciences, as well as some of my background in research, as well as mostly current initiatives of SEDS Canada. So I know we are a community of SEDS chapters around the world. So this is a really great initiative that SEDS Puljok had actually invited me to, and it's really nice to see our whole community in like SEDS Earth. We have this whole network, and it's nice to actually collaborate together, and I hope we can continue that in the future. So just a little bit about me. So my name is pronounced like Shakira, but with an M. So just replace the K with an M and you will say it correctly. Perfect. And then I am currently based in the Netherlands, in Noordwijk, because I'm currently working as a trainee in ESA, which is the European Space Agency, which Canada is actually a part of. So I'm very lucky to be part of that. I've been with SEDS Canada for about 3 years. I started as a staff member doing sponsorship, coordinating, and then I became a part of the board of directors as a vice president of finance, and then I applied this year to become president. So I actually am just in my master's. I'm doing a master's of science in geophysics and planetary science and space exploration, which is a lot of the applications of the different sciences that you would learn about space. So everything kind of integrates together, but I will explain more a bit later on. And I went to a school named Western University, and it is in London, not in the UK, but London, Ontario in Canada. I also study satellite remote sensing, planetary analogs like the Mars, Moon, and some of Pluto. I study mostly Arctic science and high alpine regions. So wherever there's a mountain, wherever there's a glacier, wherever there's ice or permafrost or buried ice in other planets or on Earth, I'm there. I'm also a very big science communicator. I'm also an artist and a big STEAM advocate. So a science, technology, engineering, arts, and mathematics advocate. So these are just a few pictures of me showing you where kind of I've been in my background in the research industry. So the first picture is just showing you that's in Laguna Paron. That's in the Cordillera Blanca in Peru. I studied glacial lake outburst floods there, similar to actually like what the Himalayan mountains undergo. Sometimes a dam that's closing the lake can burst, and this can cause a flood down the valley and then into the community. And it has a lot of implications for water resources, especially. And this also actually has been theorized to happen in paleo lakes, in Mars especially. So there's some papers that actually theorize that a lake had burst and that's how the crater was filled and then it got drained from water. So it has some implications as well to planetary science. The second picture is in Devon Island in Canada. This is actually a crater that was formed by an impact 23 million years ago, and I'm standing right in it. There's a lot of ice underneath, and I'm trying to calculate and try to figure out how much ice, and if so, where can we find it? So we can apply that to Mars. This is in Iceland on top of a volcano that's covered in snow and ice. And this is myself holding our CubeSat. I'm currently the ground station engineer lead for our CubeSat in collaboration with the Canadian Space Agency as well as my university. So we look a lot of on the orbit of the satellite and the decay and when it's going to be seeing Earth and when we have downlink time and uplink time and how much data volume can we get from our satellite. This is just me, fun fact, I have been dancing since I was a young kid, so I continue to do that. And this is just in the Canadian High Arctic again, doing some field work. So as you can see, I do a lot of field work and I study a lot of planets as well. So on Earth and Mars in particular, but why even study planetary analogs, they're called, such as Earth and Mars? So why should we even care about comparing Mars to Earth? So the reason is, although they are neighboring planets, they actually have a lot of similarities and differences as well. So before I actually go into that, I want to ask you all about what do you think the first word comes up, what is the first word that comes to your mind when you hear the word space exploration? So I've prepared this poll or Mentimeter for you. And I would really invite you all to go to menti.com on your phones or on your laptop. And then if you could please type in the code 1237000. And this is an interactive presentation. I don't want it to be just me talking. So I would really love to hear what your background is and what the type of audience members that we have here. So if your background is in aerospace or just any word that comes into your mind, it can be an adjective, it can be a noun, it can be astronaut, it can be satellite, it can be dreams or stars or anything. So I'll give you a few minutes to go to menti.com and type in this code. Let me know if you managed to do that. Oh, great. Okay, we have darkness, exoplanets, mystery, life. Those are very, very deep and cool topics as well. So as you can see, the biggest word actually is the most frequency. So however many times people put a certain word, it becomes bigger and bigger. So that's when you know that a lot of people have mentioned a lot of stars. So I will give you another maybe 30 seconds to type in a few words because we have quite a few people here. So it'll be really great to just talk about what everybody thinks of space exploration and what inspires them. So why are you even, if you're studying a space related topic, why are you even studying it? Because of civilization, limitless, alien life, space colonization, my dream, space mining, exoplanet, exciting. Yes, these are all like very, very relevant. Future, yeah, because space actually, regardless of what anyone says, space helps us a lot with our daily lives. I see that life and mystery are the biggest parts here. So whether that be alien life or alien, I say it just means that it's not from the origin. So it's not life as we know it here on Earth. So it could be microbial life, it could be very extremophile organisms, and the mystery of space. You guys really like the mystery of space. So that's awesome to hear. Exoplanets, I have a whole set of posters over here about exoplanets, if you can see. It's all about exoplanets, all 6 of them. So that's great. I'm in the right spot to do a presentation. Okay, now that we have this, we'll kind of come back to it at the end if you like. So we compare, well, I compare Earth and Mars because they have a lot of differences, like the atmosphere is made differently, the temperature is different, there are polar ice caps on Mars, if you didn't know that, on the north and on the south, but they're very different. They're made of different things. And here on Earth, as you said, we have life as we know it. And then on Mars, There's some Mars, although there's like some movements, there's not a lot. Like we have plate tectonics here on Earth, but we have a lot of similarities too. Like all of these listed here, but I'm going to be talking about ice. So ice can be found in the periglacial land system of Mars and Earth and other places. But periglacial just really means ground that has been frozen for a long, long time. So that kind of looks like this on Earth and on Mars. So these landforms that crack on the surface are very indicative of subsurface ice. And in the future, that's kind of what we want to use and look for, because water can be used as a resource for in situ resource utilization. So ISRU is another word. So those polygonal networks that you saw are called pattern ground, and there's a lot of different types. So I'm not going to go over every single one of them because this is just what I look at in my research. So these are formed from the freezing of the soil, the frost that you see, and then mass movement on a slope, and also wind. But we measure that. I'm more interested in the technology that we use to actually map this, that satellites or rovers can implement in future missions. So that's called LiDAR. I use light detection and ranging, which an image is as an example here, but I look at it in the Canadian High Arctic. So we look at it in Axel Heiberg. It's the second highest island in Canada, in the Arctic Circle that you see. If you look at a map, and then this is the crater that I was talking about. So this is 23 kilometers long, and this is another site that we looked at. So one is Axel Heiberg Island, and then one is Devon Island, which is the most uninhabited island in Canada, or in the world, actually. So looking just at one of the sites in Strand Fjord, the Axel Heiberg Island. So we looked at these cracks on the ground because they're very much indicative of where ice is. So we wanted to look at the patterns using satellite imagery, as well as the LiDAR that I was talking about before. And the LiDAR that we use is quite unique. It's actually on a backpack, and it shoots lasers laterally sideways, and it measures the elevation changes as you walk around with a GPS. So this data is processed, and in that little equipment there, it's actually very, very heavy. It took a whole day just to complete this small part scan that is on this area. So it's really, really, it gives us really important information. And if you put this on this instrument on a rover, or I don't think a satellite would carry this backpack instrument, but a rover, you can map in detail in high resolution the areas that you are walking on or want to explore on the surface of the planet, on any planets, the moon, for example. This is actually a part of one of the plans for the Canadian Space Agency. They've looked into an integrated vision system, which has all these components and other unique camera components. So if you zoom into one of these LiDAR images, you can actually see 2 centimeters per pixel. So that means you can see a rock anywhere in this picture if I zoomed in. So that's how high the resolution is, and the data that you get is so dense, and it's a lot. And so moving on to the next island that I went to just collect these data. So the LiDAR grids, although these look so boring, the different patterns on the ground, they actually tell a lot about the different types of soil, the different types of rocks, the different types of patterns, and how much ice is underneath. So depending on the pattern on the ground, depending on how they move, how you map them, and the statistics of that shape, you can also tell that we still don't know how to be able to estimate, but we use other technologies such as ground penetrating radar, which can penetrate down to the ground and actually measure the reflecting subsurface layers, so you can see there's ice. So these are just some pictures, like pretty pictures I wanted to show of what you can do with the data of a satellite. So you can either map them with shapes, or you can also classify them and do an automatic classification. You can do a supervised, unsupervised classification, and do a lot of artificial intelligence mapping as well on it. These are just heat maps to show the shapes. So these different shapes here are actually not very big. This is 50 meters by 50 meters. So that's not a whole big grid at all. So you can just walk past, you can walk across it for like 10 seconds, then you'll cross the whole grid. But all these forms that I've mapped, these are just heat maps of what the shapes are. So this is measuring how long they are. The longer shapes are somewhere in the whites, and then somewhere in the black shades, and then the more circular ones are also more in the white shades here. It's kind of opposite. It should be matching. So that's just what I have been looking at, but this is really important for planetary science in general, Earth analogs especially, not just for Mars, but for all other planets that we want to compare Earth to, because we don't have any other reference point. We only have Earth. We can't go to Mars yet. We can go to the moon, but we want to study and understand what we have here on Earth before we want to be an expert on Earth before we become an expert on another planet. But this is important because if I were to ask you all, which one is Mars and which one is Earth? So if you can type in the chat your answer, that would be great. So my question is, which one is Mars? So just type in a letter. Is Mars A or is Mars B? And you can type it in the chat, you can type it in the comments if you're watching on Facebook. Okay, we got A, Mars is A. If you think Mars is B, that's totally okay also. Don't be. Okay. And I'll give like 10 more seconds, 10 more seconds. Okay, so we kind of have a majority of A answers and B now coming up. Okay, so I'll give you the answer, the correct one. The correct one is A, and you're all correct if you said A, because we actually have sometimes higher resolution cameras on other planets on a satellite than we do on Earth, but these are just the same features that we're taking a picture of. These are called gullies, and they are formed from the erosion of water or the sublimation of ice. So that's really unique, and so that's why we want to compare how do these forms also happen on Mars when we see them on Earth. Is it the same process? So right now I just wanted to show you a little bit because I can show as many pictures and data as I can, but this is actually what I did every day for a whole month. I'm gonna pause it because I'm gonna make it full screen if I can, or not. It's fine. This is 20 seconds every day.
That way.
Good evening, 26.
Enjoy your night. Cheese.
And that's it. So I'm gonna pause now, and that's how basically it was for me when I was doing research in the Canadian Arctic. This was last summer, for context, last summer in August and July. But now we're gonna transition over to my favorite part and why everybody also is here, some background on SEDS Canada. So SEDS Canada, just like SEDS Pulchuk, is the same thing, and also SEDS Nepal. So like I said, we are a network of students for the exploration and development of space, and it's really great that you all are interested in space because this is why we're here. So the Canadian Students for the Exploration of Development of Space also is bilingual. We try to be because our national languages are French and English. But SEDS in general was founded in 1980 by Peter Diamandis, who is actually also the founder of the International Space University, if you've ever heard of that or ever want to go. and then also Scott Schwarman and Richard Sorkin. So shortly after that, in 1981, that's when SEDS Canada was founded by Bob Richards. And then we took a little break because I think the organization was kind of dismantled or just not seen as an organization at that point, but then it was reestablished in 2014. So we're still very young and we're still learning as we go, and SEDS Canada is always open for suggestions. And Canada, SEDS Canada is our only non-profit that's also student-run organization that's working at a national level, representing all Canadian students, wherever you may be in the world as well, but also international students. We also want to involve some of our events are also catered to not only Canadians, but everybody else, to empower and inspire students in joining the space industry. But we currently only have 32 staff members, which have worked really, really hard to make this year the best. 9 directors, which I'm a part of. So the board of directors is kind of the main body that kind of makes decisions and sets up meetings, as well as 16 board of advisors. So these are people from industry, some professors as well. So that's kind of the structure of SEDS Canada. And we're still growing. And we are just students helping students, and we all are just student volunteers, and we want to make space in Canada better for us in the future. Because you kind of have to be the change to see the change in the world, you know, so to quote that, because it's really relevant. I truly believe that. So just a little bit about SEDS Canada as well. We have some members. We have around 86 active members right now and nationwide and growing. This is as of last week, but we do have a lot of benefits that we offer for members. And so that's kind of why we set up our membership platform. And just to give you a little bit of statistics, if you're familiar with Canada's geography, so Ontario, which is most of our members are actually from Ontario, which is the southeast province, if you know where that is. So it's closest to New York in the US, if you can put yourself there geographically. And then the other provinces in Alberta, which is in the middle, British Columbia all the way to the west near the Pacific Ocean, Quebec, just on top of Ontario, and New Brunswick, Yukon, Manitoba, kind of spread out everywhere else. But our main kind of demographic are students from first year, second year, third year, and fourth year equally. So that's really great to see that, because we have not only graduating students, we have people who are interested in space in their first year, in their second year, also equally throughout their university career. And we also have graduate students. So that's people like me, who wanted to pursue a master's degree or a PhD degree. So as long as you're a student or a young professional, you are welcome to any SEDS organization. And most of our members, we also ask if they're students or working. So most of them are students, which is great. But to be a SEDS Canada member, after signing up, we do offer, like I said, some benefits in exchange for, like, I think our fee is only $12, which is being debated on right now. So we're still trying to see. We actually have, like, I think a discount. We're trying to make it free. I don't know. The other structures of SEDS organizations are very different from each other. So it depends on, like, the people that you have. So this fee basically goes to everything that SEDS Canada expends. So for example, our websites and all of that other administrative things. And then we also have a Discord server. That's how we manage our members. So we have a whole chat with members and staff and directors. And then members also get to vote, and that's the main component of it. We have bylaws because we're non-for-profit with the government. We're required to have these bylaws, and it's basically like a rule book or like a constitution. And anytime we change or remove anything or add anything, the members have to vote on that for sure, as well as voting for the directors for next year. So whoever is going to be running, the members always get a vote. And then they also get to participate in a lot of events and projects. So speaking of projects and events, SEDS Canada has several projects and events that we worked hard this year to continue because of COVID. I know a lot of people have been affected by just kind of the industry and the lockdowns, and so have we. These are actually projects from last year that were delayed, so we are just carrying them on because we've already had them planned, so it'd be really nice to continue the kind of legacy. So our first one is the Stratospheric Balloon Challenge, where you have an experiment and you can fly on a balloon. We have the Canadian Reduced Gravity Experiment, where you can experience microgravity on a parabolic flight. We have the Young Space Entrepreneurs Competition, or Y-Space, and it happens every year during our Ascension conference. So that's when they actually give their final pitches. So not just engineering, science, but we're also trying to cater to all the business and entrepreneurship industry. We also have webinar series that we're offering with SGAC, or the Space Generation Advisory Council, together with SEDS Canada. So this is just one of our first ones. We have the Kerbal Space Program, which is my favorite one. We just finished that, and we just ran that in collaboration with SEDS India, SEDS Japan, SEDS USA, Launch Canada, and SGAC UK SEDS, and then SEDS USA. So a bunch of other SEDS. So if you want to be involved as SEDS Pulchok or SEDS Nepal, I'm sure we're going to be doing it next year again. So it's going to be really great. I'll be talking about these individually later on, so I won't go into too much detail. Act in Space is another entrepreneurship one. And that's really exciting. It just finished in November. And then our national conference, open to all Canadian students, and also I think open internationally as well. And it's going to be virtual this year, and it's going to be free. So that will be fun. So the first one I'll be talking about is the Canadian Reduced Gravity Challenge. And this is in collaboration with NRC, which is the Natural Resources Canada, and the Canadian Space Agency, to fly on a plane that will take you up on a parabola, and at the very top, when you drop, you experience a bit of zero gravity, microgravity. And we have 4 teams this year, and that's from these universities over here, and you can see their logos as well. And so this will be happening hopefully in the summer, hopefully no more delays, but that's when their experiments usually happen. And it's a whole process of application, as well as critical design reviews and pre-CDR, and a lot of model reiteration and reports and stuff like that. So it's really, really a good project to practice and get project experience. So we have the Canadian Stratospheric Balloon Challenge as well, which is also in collaboration with the Canadian Space Agency, but also I think with CNES, which is the French space agency. And so these are little experiments that you can put on a stratospheric balloon that goes up into the atmosphere. And you can actually run experiments. We have 2 teams this year participating, and the flight campaign was delayed. So that's why we have more proposals that we have opened it up. And so that will be happening also in the summer, similar to the RGX, or Reduced Gravity Campaign. This is the Y-Space now. The Young Space Entrepreneurship Competition, and this is a 4-month competition that takes place during our Ascension conference. So it started in October, the signups, and teams have been working hard to actually complete their projects and present their pitch and come up with a space entrepreneurship integration kind of company or startup. And the idea is already fully funded. And so we hope to hear really great ideas from them. This is just a distribution of the participants. We have 20 this year, so this is really great. And we'll hear all their pitches soon. And like I said, this is most of our students are bachelor or undergraduate students, so that's really awesome as well. So we have next is the SGAC SEDS Canada webinar series, and this is open to worldwide actually. So this is a pilot initiative that we started because of World Space Week this year. Excuse me. And our goal is essentially to connect everyone in Canada, and so that we can engage students and young professionals, because Canada is a little big. So even with COVID and different time zones, we really wanted to still have an accessible event that everybody can attend, even if it's not in person. So not everybody has to go to, say, Toronto or something, because not everybody can manage that. But we're going to be running our second one, as well as third one, as well as a fourth one, hopefully soon. So that's coming up. And then some of our other events include NASA Space Apps, which I know is an international initiative. And so we have we have 5 cities across Canada this year that we've started a Space Apps hackathon in, or hosted one. And these are just some of the winners. And this hackathon occurred for 3 or 2 days, from October 2nd to 4th. So that's in Vancouver, Calgary, Hamilton, Toronto, and Halifax. So this is kind of the southern Canada part that we kind of reached, and hopefully more next year. But the Kerbal Space Program, like I said, is an international collaboration. So this is the most interesting, I think, distribution that I will show you, because it's mostly it's basically everywhere in the world. So we have SEDS India participants, we have SEDS Japan, even though it's only small. We have the SGAC, which is worldwide, so I'm really sure where they're from. Could be in Germany, could be in Austria, could be in Canada, and then we also have UK, in England, as well as Scotland and Ireland, Launch Canada, and then also SEDS Canada. So most of our participants, although they were in North America, there's also some reach in Europe, and also some reach in Asia, and also some in Africa, South Africa as well, and Middle East and Oceania. So, but the Kerbal Space Program, if you didn't know, if you haven't played the video game yet, it's a video game simulation that allows you to actually fly rockets. Or if you're interested in aerospace, I think KSP is a really good software to just have and practice. So you it actually teaches you a lot, including rocketry and the simple concepts of how to build a rocket and fuel and how to plan an orbit around the moon and maneuvers. So it's really great. And I think we're going to be doing it again next year because it was successful this year as well. So this is one of the last ones. We have Act in Space. Like I said, it was an entrepreneurship competition, but there's 3 themes that they had to do. So everyday life, business, for Space 4.0, and humanitarian. So these are just themes, and this is open, I think, worldwide. So even SEDS Pulchok or SEDS Nepal can actually participate in Act in Space. I think it's hosted by the French Space Agency, or somewhere in Europe, but it's worldwide. So anyone can really participate if you just have teams. If you're interested in entrepreneurship and engineering, if you have an idea. So these are the winners. And what I wanted to point out was the first place winners is actually a family. So that was really cute, because it wasn't like a set of engineers, it wasn't a set of scientists, but it was a group of, I'm pretty sure the parents were engineers, but it was a family who won the competition. And also some other initiatives in Canada. Since we're trying to increase our reach in the whole country, we've recruited some regional representatives, and they're from every single province in Canada, and we're trying to collaborate so that we can actually have a more cohesive perspective of what students are looking like in the north, students looking like in the west, and all of that as well. But I think just coming up to the end of the presentation, I just wanted to present what we were doing this week specifically. So we have the SEDS Giving Tuesday, or the season of giving, this week. And because it's the holidays, it's really nice also that we wanted to do this campaign. So this is just, if you wanted to participate in any of them, I think today we have our Among Us game night. So feel free. I am inviting you all to go play SEDS Among Us if you want to. There's more details in our Instagram if you wanted to look. But yeah, so we have one more event coming up tomorrow. But coming up next, other than this week, obviously December we have a break and exams. So good luck to everybody who has exams. And then in January we have a few plans ahead, kind of just wanting to increase our membership as well, planning more to cater to that. And then in February and March, we have our conference. Like I said, Ascension is what it's called. And that's also open to internationally. So feel free to also attend. I'm also inviting you all to that. It's not just exclusive to all Canada, it's for everybody. And then there's a lot of great talks and a lot of great networking sessions as well. So it'll be really good. And then in July is when we have the stratospheric balloon experiments and the parabolic flight experiments fly. So hopefully, hopefully we do that. But that is, I think, all for SEDS Canada. But we really appreciate your invitation to come here, and we really thank you for coming and your time and we look forward to collaborating more in the future. Just let me know, let anybody know in SEDS Canada, just shoot us a message if you have a question. And if you have any questions now, I'd love to answer any if you have any. But that's it for me.
Thank you, Samara. It was a wonderful presentation. And if the audience has questions, they can drop it in the chat box or you can ask live. And for now, Roshni, can you do the honors of asking questions?
Thank you, ma'am. It was a very beautiful presentation by you. Now we have a lot of questions and I will be asking one by one.
Okay, I'm ready.
Okay, I will ask first of all my questions, then I will go to the audience questions. What kind of mainly informations do we get from just learning the geography of any planets?
So by geography, do you mean the parts of the planet, or do you mean geology, like the rocks?
Yeah, like the rocks, the landscapes.
Yeah, so the landscapes of every planet are basically a window to the planet's past. So any rock that you pick up, or if you're in Nepal or if you're in the mountains, if you just look at them, those were formed not now, but a long time ago. So they can give you an idea of what the Earth was like a long time ago. And so that's the idea that's the same idea for Mars. So if you look at rocks on Mars, or I don't know, say sand on Mars, which you can actually collect and then turn into energy, and also as a resource, people are trying to build houses and structures on the moon with the regolith and all of that. So that's really important to know, because you need to know the structure of these materials, because if you are to go to Mars, are you going to bring a house or are you going to bring a car? Are you going to bring water there? So how you understand your environment is how you will be able to actually succeed in that environment. So it's really important, and that's why we have these missions to study these rocks. We have Curiosity, we have Perseverance, and we have sample return missions, because we want to learn what is Mars made of. Because still to this point, although we have really good research and ideas, we still don't know how much ice is underneath the surface of Mars. We know some patches where there is, but we have not confirmed it ever on the ground. Oh, actually, we have with the Phoenix lander, where it kind of dug and it saw ice, but we've never confirmed that how much ice is actually underneath if we're like standing on it. So it's, yeah, so that was my long answer. I'm sorry for that so long.
No, it was very interesting to know all these facts.
Yeah.
And I would like to not just about Mars. Can we relate the environment of these alpine environments of Earth to the moons of Jupiter and Saturn, where ice are found, like Europa?
Mm-hmm. Yeah, so one of the analog sites also is Titan. So there's a mission in Titan going, I think, in a few years. It's called Dragonfly, and it's a helicopter drone, and it's actually going to be mapping some radar satellite imagery of the actual moon of Jupiter. So the moons of Jupiter are icy, and there's another one that's volcanic, Io. So these are all very good candidates as well, and also for the exploration of life. So life tends to start where it's, I guess, wet also, and has resources, not but typically where there is water, there is likely to be life. So that's why everybody is trying to find life and water as well in any planet. So Titan is very cool, as well as Europa, as well as other moons of any other planets, because some of them have plumes, some of them are very, very hot. So these extreme environments can host extreme species as well. And we have those here on Earth as well. So there's species, extremophiles, that live in volcanoes. There's some that live under Antarctica in a glacier that's just been discovered after like billions of years. So you never know.
So I have one more question.
Yeah.
After the discovery of phosphine in the atmosphere of Venus, scientists predict there could be life in Venus, but there is no ice there. So why we always search for ice and water in other planets to have life?
Yeah, so I don't know if I can speak much on Venus, but in the clouds of Venus, the phosphine that they found, the molecule, that is one of the ingredients for life, basically. So I'm not sure if water definitely does not have phosphine, but to live and to breathe, you need oxygen, and so that's also one of the components of water. But phosphine, I'm not sure. I don't know much research about atmospheres, especially the ones on Venus, but I can tell you that the search for life typically is like in extreme environments. So in some places they try to find water, but in some they found now that obviously it doesn't just have to be where water is. It can be where clouds are or where other molecules are. So it really depends. And what type of life like we're defining is also, you have to be very careful. So is it bacteria? Like, is it, how small is it? Is it like a, yeah. So I think that's all, like we need more missions to go and explore and look at these things. But we have such like kind of limited capabilities. So that's why we take advantage of what we can do here.
Thank you, Samara. So we have our first question in the chat box. So Ashish wants to know about the space entrepreneurial challenge, and he wants to know what kinds of problems people work on, and what kinds of idea people develop on that.
Yes, yes. So for the entrepreneurial challenge, so it can be any idea that you have. It just has to have a space application or component. So one of the examples and kinds of problems that people work on. So for example, accessing satellite imagery sometimes is quite difficult, and the data is like hidden behind a website, and you can't find it anywhere. It's basically really hard. So one team has made it an idea to make a software to compile all of these satellite images and to make a classification kind of software that you can just type in, okay, I want to get a satellite imagery of Nepal. And then it shows you all the satellites and then the satellite images for the days of the year that you picked. So to make everything more accessible to everybody. So that's only like one of the ideas. So a satellite managing software, but you can also be very creative about it. I can check about what other teams have done in the past if you're really interested. Or you can also check it out on our website. If you go to seds.ca, and we have Y Space there, and you can see what other teams have done in the past and what they've pitched. There's also some that have pitched, I think, have cleaning space. So clean space, kind of, it's a big initiative now because of space debris. I don't know if you've heard of some satellites colliding into each other, colliding into an asteroid. So these little microparticles of these satellites and components actually can be a big hazard to other satellites. So that's why it's really important to have plans in place. So one team is focusing on not this year, but I just know in general, I know teams are focusing on how to make a business plan to have a satellite that's collecting all the space debris. But yeah, feel free to visit our website and ask for more. Our projects chair, Kristen, is in charge of that, so I can also ask her if you're really interested.
Okay, thank you, Samara. So Ankit wants to know, this is a vague question, but he wants to know, are we really close to finding a life in outer space? Or how close are we to finding life in outer space?
Yeah, I'm not sure about that question. It depends really, like I said, I keep saying, so life, when we say it, it's like, do you mean people? Do you mean animals? Do you mean plants? So like life here on Earth is very different because we define life here on Earth. We've defined it as anything that breathes, anything that eats, anything that reproduces. So that's kind of our definition of life. But if you go to another planet, obviously, you will not find a civilized group of humans or planets, or I mean, I don't know that actually. You might, I don't know. But so I don't know how close we are, but that's why we have all these missions, because some of them, to plan a planetary mission, you have to have defined goals. And one of them is life. So it's not just science exploration and looking at the rocks and whatever, but one of them is life. So it's a main component of space exploration for sure, that drives us to see who else is out there or what else is out there. But likely, you will probably find signs of life as bacteria or micro bacteria, cyanobacteria maybe, I don't know, but very, very, very different from life here on Earth. But I don't know how close we are. We've been doing it for a long time.
Okay, so Sunil says that
Yes.
later that he can send people on Mars by 2023. What's your take on that? And how revolutionary would it be?
Yes. Okay. I also see the question in the chat. So Elon Musk speculated that he can land people on. I think anything is possible. But I also know that to get to Mars, we need to go to the moon first. Because if you don't know how long it takes to Mars, it takes like 9 months to get to Mars. Okay, so there's a lot of resources that you need in order to do that. I don't think we've ever had a space mission that long with a crewed mission specifically. So we've definitely had like deep space missions for sure. Like their satellites have been sent to Neptune, Ultima Thule, all the way down across the solar system. But to land people means you have to bring people and you have to bring them back. So there's a lot of components to look at that, and there's space is an interesting field. So this is great that you all are interested in it, because this is where kind of space ethics comes in, or space law. It's an actual field, because how are you going to set rules when you land on the planet? Is this going to be the territory of Elon Musk, or is this going to be the territory of the United States? Like how there's also the planetary protection law or program, which means you can't you try to do the least invasive kind of techniques on a planet. So you cannot bring something that could infect the whole planet and ruin it from Earth, especially. That's why we have such different, very strict protocols with space flight and human space flight in general. But there's a lot of things, like how many people is Elon Musk going to take? I know he's trying to launch this whole commercial space where you can fly, like normal people can fly on a rocket and just go. And I think, yeah, that may happen by 2023, but I don't know on Mars though, if like he can land people, but can he bring them back? Is that the goal, or is it a one-way mission? I'm not sure. And how revolutionary would it be for the exploration of other planets? That would be quite revolutionary if you were to land people on Mars, 100%. And I think the first humans on Mars will be in our lifetime. Like it can be one of you guys, it can be our children, it can be it'll be earlier than that. It can literally be one of us. So yeah, just think about, so it's just a lot to think about, and I don't really know the answer to that question fully, but my take is I'm not sure if he's going to be able to do that. Like I know he's done amazing things as well, but to the moon first.
Yeah, listening to your answers, enthusiastic answers, the questions are lining up. So let's get through them.
Okay.
And Abby asks, Water is vital for life, so how can research on Earth's ice be utilized in ice found under Mars' surface? How can it support the theory of existence of life?
Yeah, so although I don't study astrobiology, I study geology. So life is just, ice is just one of those components where there has been some proposals of using ice and mining ice so that you can have fuel for the future. But also, like I said, in Antarctica, in Iceland, in I think Argentina, there's a lot of studies of cryobiology, which is essentially ice and biology. So people look at these bacteria that's growing under ice sheets or under glaciers because they're actually thriving in these environments. So that's quite different on Mars because even we've never found like that kind of detail. We've never gone to Mars and actually looked at the ice caps. But I think the first step before even finding life is to find ice. So that's what I'm really focused on before skipping ahead. Like life is just one of the main driving motivations. But really, I have to take a step back and first, we know there is ice. We just don't know where and how much. So that's the first question you have to answer. There's a lot of unknowns, so it's a lot of fill in the blanks as you go.
So another question, Pratibha asks, do the changes in the ice forms affect the rotation of gravity of Earth?
Do you mean um, like when they melt? Do the changes in ice forms?
Yeah,
When
sort
so
of.
when glaciers melt. So I it does not affect the gravity of the Earth. I don't believe so. But with climate change, there's also a lot of things happening that are changing Earth. But the gravity of the Earth really depends on the mass of like the geologic mass of like the actual components of the core, the mantle, and then the crust, and what makes all of those. So melting ice is very minute, like very, very small and negligible.
So Sayan asks, experimentation on space using student satellites has become more and more accessible. How do you think students and space enthusiasts can be more responsible about the space debris issue without compromising their mission and experiments? Once again, that issue that you brought a while ago.
Mm-hmm. Yeah, so I especially by student satellites, I'm gonna give an example of CubeSats. Yeah, exactly. Um, so CubeSats, nano satellites, those ones. So if I were to find a space debris photo of satellites currently, but in 2020 orbiting Earth, it'd look like a beehive. It would look literally like bees going crazy because there's a lot that we don't see, but they have different allocations and altitude. So like the International Space Station is in 450 kilometers altitude. And so it ensures that it will not bump into a satellite. So it's just the unique instance when a CubeSat, say, goes, I don't know, crazy and gets off of orbit. Usually the first thing it's going to do is the decay of the orbit is going to go down back to Earth. And usually CubeSats and nanosatellites actually dissolve in the atmosphere. So usually there's no space debris, but because those satellites disintegrate in the atmosphere before they even hit Earth. So some don't even hit Earth because they just catch on fire during the atmosphere, but some, I've not heard of a case where a satellite was in there was a satellite that was in danger of crashing into one, but I don't think I've heard of a case unless someone has of a satellite that actually has crashed into another satellite. Oh, actually, there was an incident also like that, but I just don't know what it is. But I don't really like know how to fix it. I know there's a few missions. For example, DART is a mission by NASA, and it's a mission that's essentially going to like give a nudge to a satellite if it's off orbit, so to get it back into orbit. So it's kind of like a what do you call it? Someone just walking around space and taking care of everybody's that they're not bumping into each other. So people are thinking about this, and people are trying to launch satellites to help satellites, but also that's a controversy again, because why are you trying to launch satellites if you're trying to fix the satellite issue? So it really depends. So it's a big topic of discussion right now. So students, for example, can't really do much because we're just going to continue building our CubeSats because we need the experience, and we need to like prove that we can launch that to space as well. So it's not like I'm not going to launch a satellite anymore because I care about space debris. You can do that as well if you want, but for now, I don't think there's anything really that we can do, and just basically plan and do a very in-depth study on your orbit, I guess. But that's also really unpredictable.
So yeah, adding on that question, Asix asks that why are CubeSats really important if they just create debris in it?
Yeah, so CubeSats are important because not only are they really small, so they're easy to launch. So for example, the CubeSats that I'm working on is part of 12 other CubeSats, and they're going to be launched from the International Space Station. Whereas if I was to build a satellite, obviously it's a huge project and you can only have one. So these CubeSats can actually inform a lot of things about one specific topic. So for example, if I want to measure the radiation in space, that only needs one instrument in a CubeSat and launch. So these projects, I think, are more catered to students. So CubeSats and nanosatellites in general are important because it paves the way for us to enter into the space industry because of our experience, and also wanting to build something for space. So it's kind of like a stepping stone. You can't just build a satellite, but CubeSats kind of are more, I don't want to say environmentally friendly, space friendly, but like I said, they can just go down and disintegrate into the atmosphere. They're not a hazard, I don't think, and they're very useful. It depends on their goal, really. Not a lot of countries can afford launching a whole big satellite as well, so CubeSats are a really good way to actually go to space for a country. But yeah, that was my answer to that question.
Sunil has an explosive question. What's your take on terraforming Mars? Can't we just nuke it to release the ice lying within the surface?
No, I don't think so. So nuking is definitely against the law of the Planetary Protection Program. So anything that's invasive, like I said, we cannot do on a planet. So we have to be the most careful. Samples even that we take from other planets, like only maybe like 50 scientists see them. So they're not in a museum, or maybe some of them are. They're not passed around from student in a lab. So they're very, very like sacred to just have. But terraforming Mars, I'm not sure how I feel about that yet, because I'm a very big advocate for Earth observation and climate on Earth. So if we can't fix what's happening on Earth first, why are we looking at another planet kind of so we have to take care of our own planet first before kind of moving on to another one, which is my opinion only, but everybody has opinions. So if Elon Musk wants to terraform Mars, I can't stop him, but yeah.
So Amit asks, are we doing this space exploration for just finding an alternate habitat, or else something else?
I don't know. You guys tell me. So this is a good question for everybody. This is like a question that all scientists and engineers ask. So why are we even going and exploring space? Why can't we just stay home and do another job and not be in it? Not launch rockets or not launch. My answer to this is very simple, because space allows us to innovate and come up with new ideas. So an example of that is not just for new habitation, but we use space exploration in everyday life. So Wi-Fi, for example, you guys would not have Wi-Fi if it was not for space exploration, because satellites provide us with broadband internet. You will not have ATM machines. Innovation also comes in the forms not just of satellites, but of human exploration. So when the astronauts moonwalked on the moon, so Neil Armstrong and all of that. So actually in spacesuits, if you look at the shoes, those shoes were actually first made by Nike, because so these are called what's it called? Spin-offs, space spin-offs, if you've ever heard of them. So Nike created these shoes that have a rubber sole so that there's more bounce and buoyancy. And NASA and astronauts took that and implemented it into their spacesuit design. Tennis rackets, if you play tennis, the stick, or hockey in Canada, tennis, badminton, if you take the racket, usually back then it was made of wood, but now it's made of nanofiber, which was originally made for space exploration. Your phones, if you have a phone, the cameras on your phone, they were originally made for astronauts in the space station. That cameras back then were like this big, like the size of your screen. So to get the camera, because we wanted everything in space very compact, and we cannot afford to bring a whole TV-sized camera to the space station. So they innovated and made camera sizes and reduced them to your phone's camera, in order to actually build something for the space station, but now you have on your phone. So everything, if you look around you, is related to space somehow in some form, like a CT scan in the hospital. That technology and the physics, medical physics, was made for space exploration before it was made for satellites, actually, before it was made for the medical hospitals. So see, there's a lot of things around you that were made from space, and we innovated and created these incredible technologies that we're now using every day, and we sort of just neglect. We're just like, oh yeah, I have a phone, but your camera was made for space. So you can look up all other types. Yeah, you can look up all other types of spin-offs, but there's so much more that I'm definitely forgetting. I will remember some of them.
Wow,
yeah,
that's a
those are-
nice answer. So we are out of questions, but I have one of my own, and
Okay.
this is a long question, so brace yourself. So my question is, participation of women in STEM field has been a hot topic that comes up quite often, you know. And since you're a huge advocate for the STEM field yourself, and also president of the SETS Canada, what have been the changes in this field since the first time you joined in, and where you are now?
So I think your question cut off at the first sentence, but can you repeat it again?
Okay, so the problem of participation of women in STEM field comes up often, and since you are a huge advocate of this field, and also I was also a president of SETS Canada, so what have been the changes you've yourself experienced in this field?
So it's definitely a process, I think. I think everybody is aware that women are oppressed and women are like, they need to be put in the spotlight. But I think if we were all equal, so I just moderated a panel for women in space for the Canadian Space Summit. And one of the speakers were, what really hit me was, if women weren't, women in space or women in science, women in STEM were not a problem, we would not even have this panel. Because imagine if we had men in space panels or men in science. So it's kind of tokenizing women and putting us in the spotlight, because we have been oppressed, especially if you're white, a white male and male. That's usually one of the biggest components, I think, that was part of that discussion. You also can be a really good ally to women in general, or just to like everybody, really. So to be a good ally, you just need to educate yourself, and to be aware of what your language that you're using, especially in Canada. Sometimes we introduce ourselves with pronouns. So say, my name is Shamira, my pronouns are she and her, because sometimes people, you don't know what people, where people come from, and what their background is. So yeah, so that's kind of, I think now it's really improving, and I think we still have more work to do for sure, but it's definitely going in the right direction. And yeah, I really like being a woman in space and in SEDS Canada. So I think SEDS Canada is a very diverse organization as well. So in Canada, it's very multicultural, but more importantly, the staff and the board of directors are so inclusive, and they're just all very collaborative with each other as well. So I'm really proud to be part of a team that's like fostering that environment. It's really nice to work in that environment. So I'm trying to implement some training for equity, diversity, and inclusion for the whole organization, because I think everybody needs to be made aware just of those concepts. So it'd be really good also for everybody to just like learn about things that are like top topics of social politics, of women or LGBTQA community, or yeah, and just not to be ignorant of the fact that some people are different. It's okay to be different. Yeah.
Yeah, so Sunil, we do too. So what advices would you give us or our community, says Puljak and says Nepal, for moving forward?
Yes, that's a good last question. So I feel like everybody here is in undergrad. So I would say,
Yes.
if to my undergrad self, if I was still an undergrad, to just go for it. So I would say try new things, because for me, I always like challenges. I don't know if you like challenges, but I would just try everything and be open-minded all the time. Because if you are someone that doesn't like feedback or doesn't like criticism, I think that is a really big component of like not being successful in something, because you need to be able to take feedback, even though it's bad, even though it's good. So any feedback is good feedback. So I always would say keep an open mind, and really go for it. If you have something, if you have a goal in life, if you want to be an aerospace engineer as well as a singer, go for those, both of those. So anything is possible, really. So I would just say yes to a lot of opportunities, but also learn how to say no, because sometimes it's up to you. It's everybody's different. So those are my advice, but you can take it. You don't have to take it.
It will definitely take that. Samara, it's great advice. And I really enjoyed your presentation and the enthusiasm in your talks and the presentation of the videos and everything. It really invigorated my spirit towards space. So we are grateful to have you. And I guess this shall be the end of this talk show session. Would
Okay.
anyone like to add a few words? The president or of sets
Maybe
or
I should turn my camera. Um, on behalf of Seth Pultuk, I would like to take this opportunity to thank Mrs. Samara for taking time out of her busy schedule, sharing the research unraveling journey from Canada to ESA, about the SETS Canada and the events it organized. And I find it really I find it really this event very insightful. I hope everyone finds this event very insightful as well. And I'm also thankful to our colleagues who have been monitoring this session, and associates of SETS Nepal and chapter, and finally viewers who's watching and listening also live, uh, asking the questions, keeping the session interactive. We'll again bring this type of space talk soon. So if you guys really want to get involved in space projects, so we are about to reopening our forums for general members in about 2 or 3 days. So please feel free to fill the form. And Ms. Samurai, yeah, if you really want us to collaborate in different projects, we're happy to join. And I really want to thank you again. And I want to end this session wishing you all the best in the future, and good evening, everyone. Thank you.